This is the nature of things.
I'm Jennifer Gardy. As a scientist, I'm always looking to the future to see what happens next.
And really, wouldn't all of us love a peek into the future?
Especially if it concerns our health.
In the not-too-distant future, 3D scanning and 3D printing replacement body parts on demand could be our new reality.
We could be cruising along in driverless cars.
We're doing 120 clicks, and get this car is driving itself.
And what about the natural world?
In the future, doctors might be prescribing a 30-minute walk in the woods to counteract nature deficit disorder.
Will tomorrow's forests be born in labs?
And one day, they just might help to save the planet.
All of us live in a world of constant change, and believe me, it can be a challenge just keeping up. Innovations are always waiting just around the corner. So we thought we'd explore what some scientists are currently doing that could shape our dreams of the future.
First stop on my journey is New York City for the 3D print show.
Great. Does it look fantastic? Oh, yeah.
Judging from the sheer volume of contributors here, it's clear that this technology is going to play a big part in our future. 3D printers have become cheaper and more accessible. They can print everything from widgets for machinery to toys, and now they can even print an entire house. 3D printers work by laying down successive layers of all kinds of inks, like plastic, metal, or even candy. Almost anything seems possible.
I mean, look at this. This dress is entirely 3D printed. Cool. This is Barack Obama's voice 3D printed.
3D printing that has the potential to revolutionize the way we make almost everything.
So cool. But there's more to 3D printing than just the cool factor.
In the field of medicine, 3D printing is creating physical models from MRI or CAT scans for training and prepping for surgery. And already, millions of people are walking around with customized hearing aids and dental implants. And soon, disabled kids in emerging nations will benefit from 3D printed prosthetics thanks to a team that includes social scientists at the University of Toronto.
So we're just going to start up the software we're using for this.
PhD student Ginger Coons walks me through the 3D printing process they're developing. First step, a scan.
So we can just scan your legs, as we would do with a child needing a prosthetic.
Prosthetic technicians will be able to use this simple technology to capture the unique shape where a child has lost a limb.
Just slowly move around you, and we're done. That's it.
All right. So what kind of 3D scanner do you need for rolling out this project?
So it's a standard 3D scanner that you'd get with a video game console, actually. It's an RGBD camera. So what that means is red, green, blue, and depth.
Oh, okay.
Yeah, and it bounces out a laser, bounces it off of the object, and sends back the necessary information. And it's darn cheap.
How cheap is darn cheap?
It's about $200.
That's incredible.
Yeah.
You know, people who've never had any experience with 3D modeling are using this software, and so we have to make it accessible to them.
Ryan Schmidt is with 3D software company Autodesk. He's designing simple-to-use tools for modeling.
So walk me through what we're looking at here. This is obviously a leg and a knee joint.
Right, so that's the raw scan data.
Yeah.
And so the first step in this process is to create a smoother surface that we can basically use as the inner shell of the socket. So,
In only a few minutes, Ryan shapes the model to create a customized socket.
so now it'll shape the top a little bit.
Cool.
The printing process they're developing is going to fill a need on the other side of the world.
This is basically done. Now we can send this to the printer.
That's amazing.
Uganda, many children have lost limbs due to bone disease, infections, or violence, and few are able to get prosthetics. Korsu Rehabilitation Hospital in Entebbe can't keep up with the demand. Development organization CBM had an idea.
We know for a fact that there are thousands of kids who just don't have the artificial limbs they need to live, rich, full lives. And so we want to help fill that gap here with 3D technology.
The most important part in making a socket for an artificial limb is ensuring that it's a good fit and is comfortable. And since kids grow so quickly, the sockets will need to be replaced on a regular basis. To make one in the conventional way is expensive, time-consuming, and requires skilled technicians. And there just aren't enough of them.
The suspension is only here.
Moses Koesa, the senior orthopedic technologist at the hospital, would like to reduce the amount of time it takes to make a socket.
From the start to the finish of one kid, through a long process, it takes 5 days. I think with the 3D, we can eliminate some of the steps.
The plan is to be able to produce 3D printed sockets on site in around 10 hours.
So, Ginger, is this what's actually going to be set up in Uganda?
Yeah, basically. It's a 3D printer. We'd have it as part of a setup in the hospital. And it's kind of like a hot glue gun, actually.
Okay. This is what's feeding it, this little string of material. I can see kind of a white filament inside.
Yeah, and that's the right word for it, actually. It's called filament. There's a spool of it on the back of the printer. It feeds through this tube into a heater.
Yep.
And this little heating element then spits it out through a little tiny nozzle.
Yeah.
Yeah, and you get this sort of very thin.
Oh, this is it.
Yeah. So that's what it's like when it's been spat out.
Okay, and this is PLA, polylactic acid?
Yeah, this is PLA, which is a corn-based plastic.
That's fantastic.
But there are still many challenges ahead.
The biggest issues that we're dealing with right now just have to do with figuring out the ways to make these technologies reliable, to create not just a solution that will work here in the lab, but one that will actually move into the Ugandan context and can continue to function. And we're ultimately also starting now to think about scalability. We don't want to just make one single spot where they can produce these prosthetics, but also to figure out ways to move outside of that initial context.
Moses now has a test socket that was 3D printed in Toronto. So the team is finally able to discuss specifics of the design.
Are you looking at transtibial sockets only or even transfemoral and other sockets?
I think we should get the transtibial working and then move on to the transfemoral.
I think the transtibial will work.
You think it'll work?
I think we are good to go.
That's very good news.
In terms of a timeline, what are you looking at for, say, getting the first 3D printed socket onto a child?
So what we're looking at right now is testing here in Canada, and then we're hoping to be able to actually be on the ground in Uganda producing and testing these within about 8 or 9 months. Great.
But 3D printing is moving well beyond plastics. Scientists are taking the technology to the next level. They're using printer inks that are made with living cells, and they're creating increasingly complex biological materials like cartilage, blood vessels, skin, and liver tissue. Cornell University in Ithaca, New York is a hotbed for 3D printing innovation. One of its leading researchers is Hod Lipson.
Bioprinting is a little bit more like planting a garden than really making an object. When you print something in plastic, you print it and you have it in the end, you can take it out, you can use it. With biology, you put the cells in the right place, you incubate them, they have to then grow for a while and become something else. And 3D printing is just the beginning of the journey.
Ready.
On the other side of campus, I'm having my ear photographed by a 3D camera. Why? because scientists here can grow actual human cartilage. These implants would use the patient's own cells, which would eliminate the risk of rejection. The cells would also continue to grow, helping integration with the body.
How exactly does the process work? If Van Gogh were to come in here, for example, and say, Larry, make me an ear, what would you do?
Right, so we want a material that is a liquid when we want it to be and a solid when we want it to be.
Okay.
So collagen is nice because it's a liquid, it's soluble at low temperature and low pH. So we can dissolve it, put cells in it.
Yep.
In the case of a printer like this, we can load all of that into the syringe, which is then deposited on this stage, which is actually heated, so that right when the drop hits the stage, it warms up and it gels.
Solidifies.
Exactly. But really, it only takes maybe about a half an hour or an hour to really set up. So at that point, we can use it for experiments in the lab, or we can implant it in an animal, or someday, hopefully, implant it in a person.
Before they're ready to start human testing, they need to do more research into the best cell type to use.
This is something that was just made. It hasn't been grown in culture at all, but it's still, please do. You can see it's still somewhat firm. It's something that could easily be handled, easily be implanted by a surgeon at this stage. And like other engineered tissues, it will only grow and get more firm, integrate with the body when we put it inside.
Cartilage tissue is simple in structure, has no veins, and is made up of just a few cell types. But bioprinting research doesn't stop there. Scientists are also working on printing even more complex organs.
Engineers at the University of Toronto and burn surgeons at the Sunnybrook Health Sciences Centre are collaborating on 3D printing your body's largest organ, your skin.
Leanne Lang is a PhD student with the Gunther Lab at the University of Toronto. She's invented a 3D bioprinter that has the potential to revolutionize treatments for burn patients.
And so eventually when you put this on the wound, what happens is this material will degrade over time.
Oh, wow.
At the same time as the cells themselves are creating their own material. So that you are basically relying on the fact that this goes away and the cells create their own surroundings.
Amazing. It's like
At the same
dissolving
rate.
stitches.
Yes.
They disappear
Right.
as the skin knits itself together.
Exactly.
Using bioprinted skin will eliminate the need to take healthy skin grafts from burn patients.
So you've now hooked up the pump that will govern the flow
printing of the cells, yes. And that's
they're in
where
that
you
green.
start to see.
Oh, yeah. Cell material, which we've got dyed green here.
Right now we're focusing on creating the base structure of the skin, but eventually we would like to do more sweat glands, be able to control color, hair follicles. What is attractive with this platform is really the ability to controllably incorporate different materials and different cells.
As a biologist, I can't believe this. While human trials are still 2 years away, the surgeons at Canada's largest burn centre see huge potential in this technology.
We're hoping to prevent infection more effectively, having faster healing times, get the patient out again from months to weeks, to reduce infection, to reduce multi-organ failure, to even have a better outcome, not only survival-wise, but also cosmetically.
Beyond skin and ears, the most complex biological material being bioprinted so far is human liver tissue. San Diego biotech company Organovo will soon have the tissue ready for use in medical and drug research, reducing the need for animal or human testing. So, what does the distant future hold for 3D bioprinting?
Pretty soon, when you're young and healthy, you get a full body scan, you keep that on file, and when you need a new body part, you'll order it. Your knee will be on file, your meniscus, your spinal disc, all these sort of mechanical parts. But I'm pretty sure we'll move on to kidney and liver and skin and other kinds of tissue.
Rapid advances in medical and 3D printing technology are transforming medicine. Keep your eyes open for 3D printers in operating rooms near you.
After the break, I look at the technology driving cars of the future, where it turns out the driver is optional.
Dreams of the future have always included grand visions of transport, getting from A to B in a fun and effortless way. A future where traffic jams are a thing of the past and everyone is suddenly a perfect driver. Yeah, right.
When it comes to driving, most people, myself included, think we're pretty good at it. But there are a lot of bad drivers out there, and you know, these days even the good ones are facing more and more distractions.
Add drowsiness to the mix and the occasional driver error, and it becomes pretty clear we are the weak link in this relationship. But car companies want to make it better in the future. How? Remove the driver from the equation.
To get a bit of perspective on the history of the driverless car, I've come to LA to see paleofuturist Matt Novak. Matt, you are the first paleofuturist I've met. What exactly do you do?
Well, I look at past visions of the future, anything from jetpacks and meal pills to flying cars, utopias, dystopias, anything that people of the past imagine the future today ostensibly would be.
What about the vision of the highway of the future? Because one of the things when I look back to, visits to Epcot Center when I was a kid, and those this is Tomorrowland.
Well, back in 1958, Disneyland TV aired a great episode called Magic Highway USA, where we get to see this vision of the future back when our federal highway system was actually being invented. But they looked even further into driverless cars. You would get into your garage, get into the car, and everyone would have their own pods that would actually break away when you dial in where you wanted to go, and Dad would go to the office and Mom and son would go to the shopping center.
We're not quite there yet. Fast forward to 2005. This event was a breakthrough. This is the DARPA Grand Challenge, a long-distance competition for driverless cars. It's organized by the U.S. Department of Defense. Their first year out, 40 entrants, not one made it to the finish. The second year, the Stanford University team won. Which is why I've come to their Center for Automotive Research to meet Executive Director Sven Biker.
I see you've got a DeLorean,
We've got a DeLorean, yeah. That's an exciting project.
Just need a flux capacitor first.
Exactly. Working on it.
So why don't you give me a little tour here?
Sure, with pleasure. Well, let's see. This is a car that basically doesn't need a driver anymore because it has GPS that basically tells the vehicle where it is on the planet. We have multiple GPS antennas for better accuracy and so on. But there might be obstacles.
Yeah.
So you're using this laser scanner, which is this rotating sensor on top of the vehicle that has 64 beams that rotate at 15 revolutions per second and picks up 1.2 million data points a second.
Wow, that's
quite
incredible.
a lot of data. Well, laser is great for contour and everything, so you can tell, well, that probably is a person, that probably is a traffic sign or something like that, but it doesn't give you color.
Where do you get the color from?
From the camera.
Oh.
So the camera here can obviously tell you whether a traffic light is red or green. Or what else it is that you see that just gives you better accuracy if you just don't know the contour but also the color.
Yeah, and there's two of them here.
Yeah, that's right, yes. Yeah. Same as your pair of eyes. For triangulation, you get some distance information as well. Now, all of this actually is great, but it doesn't work too well in very bad weather, like heavy rain, snowfall, and so on, when you actually want more support. So you use radar.
Okay.
In front of the car.
Front.
Yes.
Let's take a look.
So we have these production-ready radars already here in front of the car.
Right
it's
under
behind
the emblem,
the logo.
So this thing's huge. You can't drive around with this in your car. How are we going to get that smaller?
It's another tough challenge.
Time for a bit of style. These cars aren't driverless yet, but they are getting pretty smart. I'm here with Christoph von Hugo. He's from Mercedes-Benz, and he is going to take me through some of the intelligent drive features available in this S-Class.
What I want you to do is maybe just pull over to the left-hand side where we have a solid lane marking.
Okay, I will purposely drift us towards the median here. Vibrates.
And you see it's also pulling you back into the road, because going over a solid lane is something that's critical, and that might actually make you run into a ditch or into another car.
That's amazing. So it can tell, the car knows the difference between one of these dashed lines and one of the solid lines.
Exactly.
Well, there's no pedestrians on the Autobahn here, so can we take this thing into the city?
We sure can.
So even if I get distracted and a pedestrian walks out in front of me, the technology will recognize this obstacle as human and immediately apply the brakes. How does it learn the difference between, a pedestrian that you really don't want to hit and something like just, a plastic bag?
The camera actually has seen a lot of pedestrians in its development process. We taught it how pedestrians, what they look like. It's seen tens of thousands of different pedestrians from all over the world, all kinds of sizes, all kinds of body shapes. So it now knows what a pedestrian looks like.
And there's what's happening? Oh, a person! Oh my goodness. It beeped and then it braked.
Exactly.
Get out of the road. Everything in this car is available right now. Technology that was once considered a high-end optional extra has become standard. This Ford Focus is designed to park itself. I just hit this button here and it'll start searching for a spot. Lasers detect exactly where my car is located in relation to the obstacles around it. In this case, other parked cars. The lasers search until they find a suitable empty spot. And it's going to give me a little alert when it finds one. It says pull forward, stop vehicle, and I put it in reverse. Watch me take my hands off the wheel. I'm still controlling the accelerator, still controlling the brake, but the car has taken over the steering. And voila, the car is parked. This technology is amazing. I mean, I've been parallel parking for almost 20 years and I still have trouble figuring out that exact geometry, but in this car, the computer does it for me. It is so much easier. One thing I'm learning on this journey, it's pretty certain that there will be some level of autonomous cars in the future. But for some of us, the transition will not be easy, and it won't happen overnight.
Since it will be in steps, I think we will slowly grow into it. That we actually warm up to the idea that cars are helping us.
Yeah.
And I really avoided the word that the car takes over, because that's a creepy thought.
Yeah.
So we need to understand what makes people feel comfortable while driving. Is it like really a sporty trajectory where you're like, oh, that drives better than me, so therefore I trust it? Or like a very relaxed, where you're like, that is a slow car, I can drive much better. So we have to figure that out, how people want to be driven.
To explore that relationship between technology and the driver, I've come to BMW headquarters in Munich, Germany. This strange-looking pod is their dynamic simulator.
Buckle up.
Will do.
Just like in a real car.
All right. This is where they test to see how humans interact with their latest innovations. With the Mercedes simulator, I was checking out their technology. With this simulator, they're checking out me. The man in the control room is recording my every movement and reaction. So all these cameras in here, I noticed, one over there, one up here. These are all trained on me right now. They're recording what I'm doing.
Exactly, so we can observe how a driver reacts to certain situations.
Watch the traffic. There's a red car behind you.
Got it.
We have to test the human's experience with this automation. We have to see if they understand the context, if they understand the mode that they're in. We have to also see if they can retake control over the automobile.
This is one of the crucial questions we have to solve in the next years. If the car detects the driver should take over, then the car has to give back the driving task to the driver.
Now, they're not going to let me drive the driverless car, which is fair enough. I wouldn't let me drive a priceless research prototype either. But I do get the next best thing. I get to ride shotgun. Here we go. One button on the steering wheel, and we are driverless, Houston. It's as simple as that. The Autobahn, open road, no speed limit, pedal to the metal. Well, not quite. Some sections of the Autobahn, like where we happen to be right now, do have speed limits which are strictly enforced.
We're getting faster now. I noticed there was a 120 speed limit sign, so we changed speed limit and the car is now accelerated up to that point. Oh my goodness.
Me as driver, I want to drive 120. That's the speed limit I have set. Now.
What makes this car so smart is all the technology. GPS, cameras, lasers, and radar allow the vehicle to scan 360 degrees up to 50 times every second. No human can do that.
The technology has to be as smart as the human being. So that means it has to be react like a driver.
Oh, this is great. We've got a little traffic jam up ahead, and it's just slowed us down beautifully and kept a really good distance between us and the car in front.
Exactly. So the car will then say, okay, driver, be careful, you may have to take over.
One thing I've learned on this journey is that the term driverless car is really a misnomer. No matter what the technology, there will always be a driver behind the wheel. And you know what? That's fine by me.
But I have to remember, for some people, cars, even driverless cars, may not be the future.
I gotta ask, what do you drive yourself?
I don't drive.
You don't?
Which, in Los Angeles...
You're waiting for the driverless car.
I'm waiting for the driverless car. No,
How's that working out for you?
Just fine. You know, people who don't live in LA are sometimes shocked that someone can live in Los Angeles without a car, but in the last 10 years, I mean, the expansion of mass transit in the city has made it so that you don't really have to, especially with services like Zipcar and other things like that. It's I don't need a car.
So we fast forward 20 years. How accurate do you think our current predictions and visions of the future will be?
Well, if I've learned anything about predictions, it's that no one knows what the future holds.
Not even the futurists?
Not even the futurists.
Well, I guess we'll have to meet back here, this same street, 20 years from now and see how it pans out.
You're on.
Next, a totally different dream of the future. You know a walk in the woods is good for you. Now, science is proving it. Today, 4 out of 5 people live in cities, and that number is going to grow in the future. As someone who loves city living, I'm okay with that. But I realize there's a cost. Scientists are discovering that we urbanites could be missing out on a part of what makes us human. Innovative new research points to links between health and a connection to nature. According to some researchers, this disconnect is leading to a condition they're calling nature deficit disorder. Have we somehow become too urbanized for our own good? With a population of over 13 million people, Tokyo is one of the most highly urbanized cities in the world. But Japan is a country of contrasts.
We're just an hour and a half outside of Tokyo at the Okutama Forest Therapy Base. It's inspired by ancient Shinto and Buddhist practices, and it is where the Japanese people come to relax. And they have a lovely word for it. Shinrin-yoku is forest bathing. It's the art of letting Mother Nature in through all of your senses.
Shinrin-yoku, yeah, very good. Okay, please, sit down, please.
Dr. Yoshifumi Miyazaki is a leading researcher studying nature as medicine.
Okay, thank you.
He's brought me here to measure the effects of being in a forest on my brain and nervous systems.
We placed an electrode on your forehead, which is to measure the prefrontal activities of your brain.
And a cute hat.
We are the only group in the world who is measuring this type of brain activity. It's important that the portable fMRI on your head is in complete darkness.
でもう一つここに今電極をつけましたけれど
We
も
place another electrode on your chest, which is for measuring the autonomic nervous activities.
Dr. Miyazaki tells me that measuring my central nervous system and blood pressure will gauge my level of relaxation or stress.
でカナダ人外国人で測定する
And Jennifer, you are the first non-Japanese or Canadian test subject.
I hope I do good. I will do
もう
well
一回じゃあ
for
もう
you.
一回やろうか
After taking baseline measurements, Dr. Miyazaki instructs me to relax and walk slowly among the cypress trees. When you're in nature, the effects are immediate and obvious, but this has never been proven scientifically. And now, Dr. Miyazaki is setting out to change that.
Evidence-based medicine is very important. It is necessary to get data, and I would like to make the new concept about the preventive medical effect by forest. 胸から胸つけてそれで頭つけて
The next day, I meet Dr. Miyazaki and his team in Tokyo's futuristic Shibuya Square to repeat the experiment.
Okay.
Okay, now what do we do?
You enjoyed walking in the forest for 10 minutes yesterday. Today, you will walk in this typical urban environment for 10 minutes to compare the two sets of data.
So I can see here that my results look very different between forest and city.
Yes. このデータ見
You
て
can
もらえ
see
ば
from this data in the forest environment, sympathetic nervous activities are low when the subject looks at nature. Sympathetic nervous activities represents a state of stress, so stress is suppressed in the forest. Your heart rate is also low.
About 12 beats per minute lower, much lower.
The data correspond.
Wow. What about the brain activities?
The data from each test demonstrate that being in the forest significantly lowered my stress levels, while being in the city increased them. I know that increased stress negatively affects our immune and digestive systems. But what if you can't escape the concrete jungle? At Baycrest's Rotman Research Institute in Toronto, Dr. Mark Berman is conducting research on mood and memory. Dr. Berman has me look at images of natural and then urban settings. He conducts a series of tests, including one called Digit Span Backwards.
9, 2, 8.
829-374.
His research shows that both memory and mood can significantly improve after simply looking at nature scenes.
Why would just looking at a series of lovely trees and ponds and things actually improve my ability to read numbers backwards?
Well, we think it has to do with a theory called attention restoration theory. And attention restoration theory sort of divides attention into two forms. So one being directed attention, where in an urban environment you tend to need to be vigilant. The other kind of attention is called involuntary attention, where you can kind of mind wander and sort of let your mind go. And we think that's restful.
Welcome.
If just looking at images of nature has benefits, what might smelling nature do? Dr. Miyazaki is exploring the role that each of our senses play. Scientists have collected a sample of phytoncides, chemicals emitted by forest plants.
Okay.
Hi.
I sit and inhale while once again Dr. Miyazaki collects the data.
You can see from the data, the left-hand side of her brain is more active. We already know from experiments based on 20 people that when you breathe in phytoncides, that's vapors released from wood, typically brain activity goes down.
Yeah, now she is sleepy.
And does Dr. Miyazaki predict prescriptions for nature walks in our future?
If we can utilize nature to help us relax, which improves our immune system, the number of people who go to the hospital will decline. I don't think many people are thinking about the use of Mother Nature in the field of preventative medicine. I would like to change this frame of thinking.
Next on my journey, a look at the future of forests. Might clones of super trees be part of the mix? There's one dream of the future that, somewhat ironically, is rooted in the past. Yet it casts a serious eye to the future of the planet. Genetic manipulation is being used to preserve what we already have, trees. But not just any trees. Trees that have withstood the test of time. Trees with what you could call super genes. As we look towards the future, one of the most serious problems facing our planet is climate change. Many believe that the secret to our survival lies here, in the DNA of ancient forests.
We're the Noah's Ark for tree genetics, but instead of bringing on animals 2 by 2, we're preserving the genetics of the largest, oldest things on Earth, the trees.
One of those believers is David Millark.
Let's go. It's probably one of the most magical rooms in the world for trees.
David runs the Archangel Ancient Tree Archive. His dream is to rebuild the old-growth forests of the world. There are more than 70 exact copies or clones of ancient tree species here.
When you clone something, it's 100% the genetic fingerprint of that tree. It is that tree. It's not real close or darn close. It is that tree.
All trees clean the atmosphere by absorbing carbon, but David Millark's interest is in ancient massive trees, what he calls champion trees. For example, just one coastal redwood offsets the emissions of 111 cars. David and his son Jake have collected samples from around the world, including ancient oaks from Robin Hood's Sherwood Forest.
What we have here is the very tip of the newest growing branches. Basically, 3,000–4,000 years, we should have a monster of a tree.
It's called micropropagation, and it uses tiny samples of plants, feeds them with heavy doses of growth hormones, then nurses them in a lab to create genetically identical copies. Most trees grow as a result of sexual reproduction, with the mom tree being pollinated by the dad tree to make a seed. Just like a human baby, it has a blend of genes from both tree parents. But with cloned trees, there's just one involved, and the offspring is the exact genetic copy of its single parent. David Millark is a fourth-generation tree nurseryman, and he uses cloning and cuttings to grow trees. The cloning has drawn a lot of attention, making him something of a celebrity. A newspaper article about David caught the attention of Keith Park, a horticulturist with the U.S. National Park Service in California. Among the largest trees on Earth are redwoods and giant sequoias. Keith had concerns about one particular sequoia, a sentimental favorite that had become diseased.
This tree is not dead yet. It's, the rumors of its demise are a little bit exaggerated.
What makes this tree special is that it was planted by John Muir, a naturalist and founder of American environmental organization, the Sierra Club. Keith decided to see if David Millart could save this tree by cloning it. The first thing he had to do was gather sample cuttings. Now, if this tree looks out of place, that's because it is. When John Muir chose to plant a sequoia in this location, he got it totally wrong.
It's not in its native habitat. It really wants to be up in the Sierra Nevada mountains with a completely different ecosystem. We see many trees of the same species in the area, and every one I've ever seen has some sign of this disease.
The disease, called Batriosphaeria dothidia, is terminal.
It attacks the leaves, it compromises the tree its own food and photosynthesize, as fully as it would normally.
The samples that Keith needed were 20 meters up, at the ends of the branches. Once gathered, he shipped them off to David Millart in Michigan.
Tell me what happened to the cuttings that he sent you.
I'm happy to say here is the world's first living clone of the John Muir giant sequoia, the last living witness to his life and times.
David Millart's cloning experiments have been successful, at least in the initial stages. As to whether Keith Park's beloved sequoia will grow to become the giant it deserves to be, only time will tell. I've come to the University of British Columbia to meet with forest geneticist Sally Aitken. She studies how forests genetically adapt to different climates. That knowledge helps us plant the right trees in the right place. When it comes to cloning ancient trees, Sally is cautious.
I have considerable doubts about whether those trees are going to be the right trees to rely on for future climates. Those trees established under very different conditions than we have today, and we don't know exactly what the conditions are that they established under. They thrived in those particular locations, but whether or not we can match them well to future conditions is another question.
As part of her study, Sally and her team are sequencing DNA from conifers.
And how much DNA sequence is there to read in a tree?
There's a huge amount. So we study conifers in my group for the most part, and conifers, like the big trees around us, have in their genome, they have about 7 times as much DNA as a human. So they have these very obese genomes.
Like David Millart, Sally Aitken is concerned that we may lose much of our forests in the ongoing battle with the effects of climate change. However, for her, diversity is the way to win this battle.
If we planted many individuals of the same clone, we would have no genetic diversity, and those individuals would all be susceptible to the same problems. Genetic diversity is good because you don't know which individuals are going to be perfectly adapted and are going to be the most fit. Having that diversity ensures that at least some individuals should be able to tolerate future conditions.
Sort of the opposite of, putting all your eggs in one basket.
That's right.
Put your eggs in multiple baskets.
Absolutely.
With all the uncertainty facing our planet's future, it's clear that biodiversity is going to be critical to maintaining the survival of amazing forests like this.
When I was young, I had a high-tech Jetsonian vision of the future, and thanks to our endless appetite for technology, some of those dreams are becoming a reality. But I've come to realize that just as important is nature and our relationship with our environment. So, my dream for the future? Well, it's cool tech and a green planet.
For decades, doctors have pointed to a prime suspect in heart attacks: cholesterol.
And so I go into the doctor and he just says, you have really high cholesterol and you have to start medication right away.
But what role does cholesterol really play in these matters of the heart?
It's really been exaggerated. I think it's partly driven by the fact that there's a lot of money there.
50% of people who have a heart attack or a stroke actually have normal cholesterol levels.
There's nothing normal about the weather anymore.
In roughly 3.5 years, we had 1,100 years of storms. There's a problem.
Weather gone wild. Doc Zone, next.
I'm Mark Kelly. We're interrupting our season premiere at the Fifth Estate to focus on the tragic events in Ottawa that have affected us all. Our teams are working right now to bring you the stories behind the attack.
The Fifth Estate, tomorrow at 9 on CBC.
Janet King, Sunday at 9 on CBC.